Hello everyone. Today I'm going to explain different ways of classifying differential equations. There are basically tons of differential equations exist in math and science fields. And the way you tackle these differential equations is by their types. As a result, there are several classifications that you can put differential equations into. I explained them in the following sections. So, classifying the equations based on their orders. So this differential equation can also be written as the first order of d of y with respect to d of x. And that is going to be equal to 8x. So because this is the first derivative of y with respect to x, we call that as the first order. In the second one, you take the third derivative of y with respect to x, and you take plus the first derivative of y with respect to x. So again, classifying equation by the order is simply you selecting you selecting the highest order in that equation. So since the highest order of differential equation here is 3, then this equation is the third order equation. And hence you have the nth order, like you're taking the nth derivative of y with respect to x, so this has to be n. Therefore, this would be the nth order differential equation. So now we get to the next section, which is classifying the equations of ordinary versus the partial equations. Imagine you have an equation like this, and let's say actually this equation is the electromotive force. The ET is the electromotive force, and the charge QT, Q is a function of T, is basically the charge which is in a circuit, and in order to define the electromotive force, this is basically the whole equation. So we call that as an ordinary differential equation because Q is only a function of T. Like, I'm trying to give you an example. So Q of T, for example, would be half T squared plus, let's say, T. So it's only a function of T. And since you're taking the derivative of Q with its only variable, which is T, then it is also called a full derivative, or it's called an ordinary differential equation. However, here on the second example, let's say if our velocity, let's say v is a velocity is a function of both x and t. This is just for the sake of example. So since you have two variables and you're taking the derivative of v only at each given time based on one of its variable, therefore you're not taking the full derivative of this equation, this function. You're only taking the derivative of part of one part of that, let's say, function. So you're only taking in the first example, you're taking the derivative of v with respect to x, not t. And on the second one, you're only taking the derivative of v with respect to t. So let's say if v was equal to 1 half x squared plus t squared. This is just one example. So at each time you have to use the squiggle sign of d, which shows you're only taking the derivative of v with respect to x, not with respect to the other variable. Therefore, you're not taking the full derivative, you're only taking the derivative of part of that function. And on the second one, it's pretty much the same story. So now we're classifying based on linear versus linearity versus non-linearity. And in this one, since we only have a power of 1 here, and we have a power of 1 here, and we have a power of 1 here, then this is linear. But if, let's say, we had a power of 2 somewhere on here, then that would become, non-linear. And here, since we have sine, therefore our equation is not going to be linear. So this one is non-linear. This one, so if it's the power of 1, just this is linear, and this is ordinary, and this is partial differential equation. And that's pretty much it. I hope you learned something new, and I'll see you in the next video. Thanks.